Hello, welcome to this webinar about the graphs in government. My name is Alessandro Svensson and I work as a Senior Solutions Marketing Manager at Neo Technology. And this is what today's agenda is going to look like. We're going to kick it off with a quick intro to some Neo4j use cases, and then we'll right into the discussion about today's topic, which is the digitization of government. I'm going to highlight some examples within e-government, money laundering, law enforcement, and security, and hope you'll enjoy it. And if you have any questions, as Corey mentioned, feel free to ask them in the question box, and we'll get back to you with answers. Yes, so let's kick off with an introduction to some Neo4j use cases. First, though, I just want to very quickly to start by talking a little bit about data structures. Of course, most people who are familiar with databases know that there's something called relational databases, and that data is structured in a relational database like this. That is tables and columns, etc. The difference between modeling data in a graph is that graphs considers relationships as first-class citizens. So this is what data will look like modeled in a graph database. And we see at Neo4j, we have a lot of different use cases at Neo where we see companies take advantage of leveraging connections in their data. Our top use cases are real-time recommendations, master data management, fraud detection, graph-based search, network and IT operations, identity and access management. And I'm just going to go through these real quickly to give you an idea of what kind of companies that we work with and some brief overview of how graphs are applied in real life, so to speak. So first off, real-time recommendations. Real-time recommendations is basically all about the connections that arise from the purchase patterns between people and products in real time, right? And here we work with companies such as Walmart. Another big use case for us is MDM, or Master Data Management, and this is because organization and product lines are inherently shaped like graphs. And a lot of global market leaders use Neo4j to master the data management. Yes, and Neo4j, of course, powers a lot of companies in this section, and for one example of companies like this is Cisco, that we have several projects with using Neo4j. Fraud detection is another big use case for graph databases, and we see a lot of top global banks and insurance companies using Neo4j to do real-time analysis with data relationships, uncovering fraud rings and other sophisticated type of scams. Graph-based search is another use case, and here we see companies using Neo4j for media libraries built around the relationships between digital assets and their attributes, enabling them graph-based search capabilities. And an example of this is Lufthansa, who uses Neo4j to manage the digital assets inside its next-generation in-flight entertainment systems. This is a very, very cool and surprisingly complex use case. Network and IT operations is another big use case for Neo4j, and this is because interconnected physical, virtual, and application layers of a network are perfectly modeled in a comprehensive Neo4j graph. And a customer example for this use case is HP, who uses Neo4j for topology analysis for big telco service providers. And finally, identity and access management. Basically, who you are, how you belong, and what you're permitted to access within an organization depends upon relationships. And here we work with large banks such as UBS. And the challenge with so-called entitlement graphs is that they need to be highly flexible, but also they can't leave any room for errors because of the sensitivity of the material you grant access to. And this is a great suit for graph databases. So this was some of the use cases that for Neo4j, and I hope this gives you an idea what kind of companies that we work with for these use cases. But today we're going to talk about the digitization of government. And basically, the use of graph databases in government is the story of how governments could make their country more secure, build better services, and to make government functions more efficient by leveraging the connections in data. And in this presentation, we want to give you an overview of how this could be done. And I'm going to highlight 4 different examples. We're going to talk about money laundering, law enforcement, security, and finally some examples within e-government. Let's start with the money laundering example. Of course, money laundering is something that is highly interesting for government functions like Treasury Department or an IRS. And the challenging within money laundering and tax evasion is that, first of all, it costs billions of dollars every year. And it's about funds traveling across a network of parties is highly complex. And consequently, this requires a technology that analyzes connections in data, and often in real time. Because money laundering is all about how funds travel across a network of parties. And without graph analysis capabilities, some of these patterns can be impossible to detect. And what we see here is a simple sketch of how this could be modeled. It's basically about deposits of so-called dirty money from different people, and money that gets washed through a complex series of transfers and then end up being clean money. So this is a very basic steps of how you could model these kind of relationships. Real examples are, of course, much more complex. And this is a real example done by the Department of Treasury's Office of Foreign Asset Control back in 2003. And it's unfolding the money laundering scheme of the Cali cartel in Colombia. And what we see here is a highly connected networks of account, assets, and people. And this sort of structures are very complex, but they're perfectly fit for graph analysis and graph databases. And one case study we're particularly proud of enabling is the International Consortium of Investigative Journalists, or the ICIJ, and how we helped them to expose highly connected networks of offshore tax structure to what they call the Panama Papers. And this has been very, very big news the last months since this was unfolded. And just to give you a comparison of the size of this leak, is that it's the biggest financial leak in the history of in history, basically. And if you compare them to NSA and Snowden and WikiLeaks, for example, that were a really big deal a couple of years ago, the Panama Papers is way more complex in terms of file sizes and the number of documents. So basically, what the ICIJ was that they used Neo4j to unfold the connection between the files that were found throughout this leak. So it's not only the documents themselves that are interesting, but how the content within these documents relate to each other. And the ICIJ said in a statement that this sort of investigation would have been impossible without the power of Neo4j and the graph database technology. It's just too complex, too many files, and too interconnected for any type of database to handle it effectively. And this is something, of course, that government functions such as the IRS or a Treasury Department could use because it handles the same sort of connections in tax evasions, etc. So to summarize this section, the use of connected analysis and graph database within FinGov is basically about how transactions occur and how money moves between assets, companies, people is highly connected. And we have a lot of experience from these use cases because we're used by many major banks for asset modeling, entitlement programs, and fraud detection. So Neo4j is used to combat advanced money laundering scheme, and because this is, of course, all about how fund travels across networks of parties. Moving on to law enforcement and the connections of data that we see there. Here, the particular challenges are that information is often stored in many different types of databases with no easy way of search and access it, which means that law enforcement agents often need to access several different databases to gather information on a single suspect or location of interest. So there's a huge disadvantage not to have the connections between data points readily apparent. So let's take a look on how data synchronization in law enforcement could work modeled in a graph. For example, we might start off with a suspect that might show up in agency records through convictions or he might be arrested before or appear in police reports. This, of course, would be stored in databases within an agency. But a suspect, of course, also have financial records and has addresses and so on, which is more of a public or civil record thing, which probably will be stored in a different database. And the suspect might own a vehicle that show up registered in traffic cameras and so on, which is traffic records. So a suspect might appear in many different databases. However, these systems are designed to relate to each other. And here Neo4j and a graph database approach will be a very effective tool to augment existing systems. Because having graph search capabilities across this data opens up for both targeted searches and advanced connected analysis. So Neo4j is used by law enforcement to track all parts of criminal investigations, including witnesses, suspects, forensic evidence, and locations. And all of these sort of data points are related directly or indirectly. So therefore, connected analysis can give law enforcement agents an important insight of who and what to investigate. Even implicit connections could unravel patterns that weren't available before. And the final example within law enforcement is, of course, fraud. And organizing a fraud ring in the real world is relatively simple and is highly connected. Just a group of people that share their personal information to create synthetic identities. For example, with just 2 individuals sharing names and social security numbers, you can create up to 4 different synthetic identities. And this is something that can be discovered with connected analysis and the use of graphs. And in this simple fraud detection example, it's relatively easy to spot outliers and anomalies to investigate with discrete analysis. The problem is that fraud rings don't operate like anomalies. They hide within normal behavior. And this is very hard to detect by systems that are looking for outliers or activities outside the normal behavior. What you have to look for here is fraudulent patterns, which is much more connected and a better suit for graph analysis and graph database. So today we see agencies that understand that they need to augment their discrete analysis capabilities with connected analysis. And whether you're dealing with a fraud ring or stolen or a synthetic identity, it's extremely powerful to use graph databases. And normally your operational data is loaded into your fraud detection application, which then conducts a wide range of discrete analysis to help your internal team to detect fraud. What Neo4j does is that Neo4j helps to extend these capabilities with connected analysis. That you can load some of the same information inside Neo4j, and Neo4j's native graph and model stores both the data and its relationships, which can help your team to detect fraud patterns as well as discover new ones. So you need both the discrete analysis and the connected analysis to provide very effective fraud detection capabilities. So to sum up the law enforcement, Neo4j is used by agencies to track all parts of criminal investigations, including witnesses, suspects, forensic evidence, and locations. And criminal investigation considers patterns in data that are both directly and indirectly related, which is a perfect fit for graphs. And law enforcement agents often need to access numerous databases and reports to gather information about a single suspect, which isn't very effective. And of course, very related to law enforcement is to talk about security. And there's a lot of challenges within security today, because security officers need to extract insights from connections within massive scale data sets. And decisions often need to be made in real time. And because of the disparate types of data, a very high level of flexibility within these systems is required. And the sensitivity of the data, of course, often requires complex structures of entitlement between access between individuals and different agencies. So this is a very complex thing. Basically, security and intelligence is the practice of extracting insights from massive scale data. And as I mentioned, often from various data sources as in real time. And deep search within these data sets is crucial when dealing with complex situations with many people involved, such as smuggling, trafficking, import of entry, ingress, and egress. So the typical use cases that we see from government is dealing with border patrol, anti-terrorism and security, and also cyber crimes. And this slide here is a very simplified way of explaining connections between different domains. Of course, names and photos will appear as IDs and passports that will show up in travel logs, which will show up how people move between locations, etc. And the security is basically about analyzing all these connections, where the challenges lie in that data is extracted from many different sources of huge data sets. And some of the data needs to be queried in real time, like customs and border control, or computer managed enforcement, like traffic cameras, etc. Other data will be batch processed, like advanced statistical analysis, for example. The point is that security officials have to deal with all kinds of data: metadata, master data, transactional data, structured and unstructured data, and for different purposes. And when you want to process the relationships within this data, you need a system that is flexible to change, that is scalable to many sorts of problems. Very, very importantly, that it's intuitive to understand and that it's instantly responsive. Basically, you need a graph database. And the final example that I want to mention is the e-government. And graphs in eGov could be found basically anywhere. We have Neo4j projects spanning from healthcare efficiency, social services programs, to infrastructure maintenance. And government is something that is quite complex in its structure, and projects are managed at different levels of government with unique funding structures, budgets, and hierarchy. And a typical division could be, depending on the country that you live in, it could be that the government is structured on a federal level, a provincial level, or a city level, which would be the case in North America, for example. And of course, all these levels are in need of effective digitization. And some of the pain points that we run into a lot when we talk to different bodies of government is challenges that are related to the inconsistency of records. There's a huge problem with legacy technology that makes operations and development both expensive and time-consuming to maintain. And this, of course, leads to a lack of efficiency. And I want to give you an example of how you can use graph databases to gain synergies in record keeping. So let's look at a very simple example of how local governments can improve services by better consistency in record keeping. First of all, the many that we have government services, it could be like traffic services or local income tax services or education and healthcare. And of course, all of this is moving online. A lot of the administration of these services are moving online. So what happens within this system is that they will use different databases to store records. And the thing with government services is that is something you don't use very consistently. So a scenario could be a person filling out personal records over time, and these records could of course change over the years. And this is what happens when you have personal records stored in separate databases for each application. So let's look how this will look stored as a graph and as a metadata function in a graph database. Then basically these structures and foundations will enable you to build more personalized experience by storing the personal records for the same person in one spot to use for all different kind of applications. But this data storage doesn't have to end with the personal recommendation, because this person will probably have relationships. He might be married to someone who has personal information that you can store that will be connected. They might be living at the same address. He might own a car and co-own a car with his wife. They might have a child together who is enrolled in a school. So these structures and foundations that you can store, when you store the relationships in a graph database, will enable you to build more personalized experiences, more relevant effective services, and also multi-platform and multi-purpose services and applications that weren't really possible before. So what we see is that we gain better services through more consistency in the data that saves a lot of time and will coordinate a lot of efforts. And this is how graphs are used to improve government services. To summarize, Neo4j and graph-based application are used to gain, of course, better access and availability. Also, graph databases eliminate duplication of records, as most government systems are powered by separate databases, as I mentioned before. So storing data as a graph provides synergies between these systems and the ability to see these connections clearly. And of course, Neo4j enables governments to cross-use data from different services, i.e. like traffic permits, local tax payments, etc., in creating efficient and multi-purpose and multi-platform services. So summing up, we talked about e-government, law enforcement, security, and money laundering schemes for for Treasury Department and revenue services. And I found this to be a very, very interesting and typical quote for this quote is from the whitehouse.gov website. It shows from the Office of E-Government and Information Technology, and it's very transparent in terms of that it shows the problems that many government faces today. And it says that the federal government largely has missed out on the transformation due to poor management of technology investment, with IT projects too often costing hundreds of millions of dollars more than they should, taking years longer than necessary to deploy, and delivering technologies that are obsolete by the time that they are completed. And I think this is a very transparent statement and shows the problems that governments face today. And I think this is both a huge opportunity and also, of course, a responsibility for everyone who works in government. So basically, it's about to choose the right database for the right job. If you have functions that requires to handle very connected data, you have to choose a graph database because it's very easy to model and maintenance, and it's easy to query, and it gives you ultra high performance for a minimal resource usage. And who's using Neo4j today? We see in government, we see everything from local governments all around Europe and North America who use Neo4j. Of course, law enforcement use Neo4j in the way that I described earlier, and also military and intelligence services around the world. We also see institutions such as University of Cambridge or the ICIJ or World Economic Forum uses Neo4j to process large amount of information. And of course, our commercial clients within the Fortune 100, such as Walmart, eBay, LinkedIn, Cisco, RBS, etc. And I also want to give a shout out before we end this short seminar for our website, neo4j.com, where you'll find a lot of valuable resources if you want to learn more. There's great material for developers who wants to learn more about Cypher queries, and architects who wants to more information regarding the product, or if you just want to learn more about our use cases. So please visit neo4j.com. I strongly urge you to do that if you want to learn more. There's a lot of good stuff there. And that was it for me. Thank you very much.